Hey, what's up? It's Jake from Nimbus DevOps, and we are finally moving into the world of container orchestration with Kubernetes. So, I'm going to go through this process that I'm going to use to pass my Certified Kubernetes Administrator certification, and I will take you along this journey. If you're trying to get certified, great, then this is one resource you can use. If you're just trying to learn, then great, this will be the perfect uh, content for you. I have some experience with Kubernetes, but I would not call myself an expert. And so, what we're trying to do is become an expert. So, for me, what that means is not taking a training course, it means going to the vendor documentation and going through all of it. So, we are on Kubernetes.io, which is the homepage for Kubernetes. And what we want to do is we want to go to the documentation page. Once in the documentation page, you'll see that um, there's several little panes here that you can look at that tell you some different places to go. But it might be kind of confusing to go, well, where do you start, right? Do you start building stuff? Do you go through walkthroughs? What do you need to know? And I personally think the Understand Kubernetes section is probably the best place to start. And if you're looking at this navigation menu on the left side, this would be under Concepts or maybe Getting Started. So when you have the Getting Started section, talks about actually installing tools and setting it up and administering and configuring, and like gets right into it. But we don't really know what we're doing yet, right? So another thing we might want to look at are the concepts. And if you look at the overview, we get into, well, what is Kubernetes and what are the components and how does this work and what's the architecture look like? And I think that this might be a better place to start. So that's where we're going to start. So in the overview section, we can look at an overview of each section. And where we're going to start is what is Kubernetes? Now, they define it as a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem, and Kubernetes services, support, and tools are widely available. So let's take a look inside. So we just read this part. What about this name? So the name originates from Greek, meaning helmsman or pilot. Kates, which is the shorthand version for Kubernetes, which has 8 letters in it, as an abbreviation, results from counting the letter. Okay, it explains that. It's an open source project from Google that was actually made available or announced at 2014. And if you've never seen the Kubernetes documentary, to look at this story, it's a great place to start in your Kubernetes journey. And they combined over 15 years of Google experience running production workloads at scale with the best of breeds ideas and practices from the community. So if you look at Kubernetes documentary, Honeypot put out an awesome video, and there's 2 parts. I will put the link to both part 1 and part 2 in this description of this video so you can go watch it for yourself, because I think that is a really, really cool place to start when you're trying to figure out what is Kubernetes and why is it such a big deal. So let's explain exactly why it's different, and get you a little bit excited about container orchestration. So traditional deployment. Here we have a visual aid that shows you hardware under an operating system under your applications, and then VMware came along and they've got hardware under an operating system under a hypervisor, which is able to host virtual machines, each with its own operating system, binaries, libraries, and applications. Containers, on the other hand, share hardware, operating system, and a container runtime. And so instead of having multiple operating systems for each virtual machine on top of the hypervisor, which has its own operating system, you just share an operating system and then a container runtime, such as Docker or etcd or something like that. And you would have your container, which only contains the minimum requirements for your application. So whatever binaries and libraries needed for that particular application. An example would be like if you needed an Nginx web server, instead of installing it on Amazon Linux 2 or Ubuntu or Red Hat or whatever, it would just be in a container with just Nginx and your app code, and then you could have a database or you could have an API or something like that, and all of that runs on a container runtime, and they have the same operating system, and it just uses the underlying operating system. So let's take a look at this. It says early on, organizations ran applications on physical servers, and there was no way to define resource boundaries for applications on a physical server, which caused resource allocation issues. So multiple apps run on a physical server. If one takes up all the resources, the other apps would underperform. So the solution would be to run each app on a different server. That doesn't scale because it's expensive. It takes forever to set up. Sometimes ordering takes physical servers takes a long time, and you end up with a bunch of empty space that you're not using. So you're actually over provisioning in this traditional deployment era. So then we moved on to virtual deployment. So a solution to that problem was virtualization, which allowed you to run multiple VMs on a single server, right? And that allowed apps to be isolated between the VMs on the same server host. And that provided some level of security because the information of one app cannot be freely accessed by another app. And it was a better utilization of resources because the physical server allowed you to scale that a little bit because you could build 2 or more servers, 10, 20, 100 servers, or I should say VMs on one physical server. They can be updated easily. You don't have to go out and buy new hardware. You don't, which reduces the time to get the hardware when you get a request for something, and you're present with a set of physical resources as a cluster of disposable virtual machines. Each VM is a full machine, right? So it has its own operating system, et cetera, on top of the hypervisor, the virtual hardware, which is the hypervisor on its own operating system. So then we get into the container deployment era, which is kind of where we're at right now. And don't get me wrong, everybody still uses all three of these right now, but what we're looking at is the container deployment era. So containers are like VMs. They have isolated properties, but they share an operating system. So they're a lot more lightweight. But just like a VM, it has its own file system. It's got some CPU, memory, some space to actually, process workloads, but they're decoupled from the underlying infrastructure, and they're portable across clouds and OS distributions. So let's say that you have a container like an Nginx container. You could run that container on Windows, you could run it on Linux, you could run it on a Mac, you can run it in VMware, you can run it in AWS, GCP, Azure, whatever, because the container doesn't care about the underlying operating system so long as it has a container runtime that can support it. So they become popular because there's some, extra benefits such as agile application creation and deployment. You've got continuous deployment integration. You can frequently change these, roll them back because the images are immutable. Dev and ops separation of concerns. So you can create application container images at build release time rather than deployment time. So you can decouple the app from the infrastructure, which is my favorite part. Observability. It not only surfaces OS level info and metrics, but also app health and other signals. You have environmental consistency across dev, test, prod, even across different clouds. Cloud and OS distribution portability. It'll run on whatever, basically. App-centric management raises the level of abstraction from running on an OS to running an app on an OS using logical resources. It's loosely coupled. It's elastic. You've got liberated microservices. Everything's broken down in small pieces, and you don't have a monolithic stack on some big single-purpose machine. You've got resource isolation and utilization. It's predictable. It's highly efficient, dense. You can pack a lot into a single host, right, or node. So why do you need Kubernetes, and what can it do? Containers are a good way to bundle and run your applications, right? In a prod environment, you need to manage containers to run apps and ensure there's no downtime. So if a container goes down, another one needs to start. You can have that handled by the system, so Kubernetes can manage that for you. The upside to that versus a VM is you don't have to provision entire operating systems, so scaling events are much faster. Kubernetes gives you the framework to run distributed systems resiliently, takes care of scaling, failover for apps, provide deployment patterns, etc. So if you're used to the cloud, you can think of this as like it manages your load balancing, your auto scaling. If you're talking like EC2, your target groups, like all that stuff, it'll handle everything, but it does it a lot faster and with a lot more lightweight, portable entities. So you can use it for service discovering, load balancing, storage orchestration, automated rollouts and rollbacks, backpinning, um, or bin packing, sorry, self-healing, secret and configuration management. Super handy. The one thing we'll say is Kubernetes is not a traditional PaaS system. A lot of people think that that's what it is. It's actually not a PaaS system. I've heard it described as a platform for platforms. It operates at a container level that rather than hardware level. Um, so it does have some things that are common in PaaS offerings like deployment, scaling, load balancing, etc. But it's not monolithic. The default solutions are optional, pluggable, and provides building blocks for you user. I mean, to be flexible to use however you want to. It doesn't limit the types of apps that are supported. It doesn't deploy source code, and does not build your app. Right? You still have to have CI/CD. It does not provide app level services such as middleware and dictate monitoring alerting solutions. It doesn't mandate some sort of configuration language, or adopt comprehensive machine configuration. And really, it's just, um, it is an orchestration system, but there's a little bit more to it than that because it actually eliminates the need for orchestration. The technical definition of orchestration is execution of a defined workflow, right? Like do this, then that, then this. But Kubernetes actually is made up of a set of independent composable control processes that continually drive current state toward a provided desired state. So it shouldn't matter how you get from A to Z. Um, Centralized controls not required, which leaves you with a system that's easy to use, powerful, robust, resilient, extensible, and it should reduce your operational overhead by not having to do the orchestration yourself, because the orchestration doesn't matter, and you can just focus on deployment or development. So that's a quick overview of Kubernetes. I'm going to start by going back and watching the documentary. I've already seen it, but I'm going to go back and watch it again, and I will put the links below. So make that the next thing you do. Take care.